my Digitization and Literary Studies MA course. I'm Zsolt Almási still, and I'm an associate professor at Péter Pázmány Catholic University. In the previous lecture, quite in harmony with the entire aim of the course, I elaborated on the concept, the soft concept of materiality, because we're interested in digital databases as a medium that presents literary works and helps literary studies in general. So in the previous lecture, as I said, I elaborated on a soft, accommodating, open concept of materiality. In the forthcoming lectures, I'm going to fill up this theoretical concept with flesh, with information, with elements that contribute to the understanding of digital databases as a medium in literary studies. In this lecture, in the present lecture, the element I'm going to add to digital databases is the understanding of the World Wide Web as we know it nowadays, as something that we take for granted, as something natural, something that has always been with us, which is of course not true. The World Wide Web had its own beginnings. Also, it had its evolution, its development to what it is nowadays. And it has layers that we also have to know for the sake of understanding the World Wide Web as context in which digital databases come down to us, through which we can have access to digital databases. I'm going to thus talk about and elaborate on the concept of the World Wide Web through looking at its history from its postulated birth to the different stages it went through, and we're going to look into the future of the World Wide Web. And also, we're going to look at the different layers of the World Wide Web as, again, elements that we have to know to be able to contextualize in an informed manner digital databases within the World Wide Web. Now, to begin with, I have to make a relevant distinction, because in everyday speech, we do not really distinguish between the Internet and the World Wide Web. But once we are at the moment of conceptualization of these terms, we have to make a possibly clear distinction between the two, between the Internet and the World Wide Web. The Internet means the infrastructure, one might even say the hardware of computers, servers communicating with each other, whereas the World Wide Web is rather the other aspect of the interconnected communication of servers and laptops and PCs, is the language, the communicative channels, the software side of the linked computers and servers. So the World Wide Web concerns the software aspect of the same thing, whereas the Internet rather refers to the hardware behind this. And naturally, the evolution of the World Wide Web is linked to the evolution of the hardware side of the coin. Now, the beginnings go back, are related first and foremost to the internet as hardware, that is, the way computers were and now are linked to each other. As many developments, as many ways to, as many technological developments, the development of the internet is very much related to military activities. We are in 1957, a year that is very important in terms of the development of technology, of the development of the internet. Because in 1957, during the Cold War, the Soviet Union sent its Sputnik into the space, which was a great achievement, but also from the perspective of the US, this seemed to have been a rather problematic, even fearful development, because the Sputnik made communication and spy work much faster and more beneficial than previously for the Russians, for the Soviet Union. Now, to counteract this, in the US, the Department of Defense launched the Advanced Research Projects Agency to counteract, to make communication within among and within information agencies faster. And took 9 years for the ARPA, the Advanced Research Projects Agency, to put down the plan and also the very first structure of a network for ARPA. It took a further year by the time the ARPANET, the Advanced Research Projects Agency Network, was launched in 1969. ARPANET provided a package related communication between 4 major nodes of computers. The first was the UCLA, University of California at Los Angeles, SRI, that is the Stanford Research Institute, the UCSB, University of California at Santa Barbara, and the University of Utah. So the ARPANET linked universities as nodes for the sake of communication. This meant, at this early stage of the ARPANET, that there was a central computer which could be accessed from a variety of nodes, the 4 ones I have mentioned, and the Department of Defense, from computers that functioned as terminals. And there was no communication between these nodes, but only through the central frame computer. So it was one can imagine this as a kind of a star-like um, um, relationship to exchange packages of information. In the center, there was the mainframe computer and the nodes, the ends, the sharp angles of the star metaphor were the nodes where computers functioned only as terminals and could communicate and exchange packages of information only in a centralized manner. Now, as time passed, there was a growth, a radical growth to the ARPANET. In 1971, there were already 15 nodes comprising 23 computers. 1973 is again an important date with respect to the growth of the ARPANET project because two countries were linked to the ARPANET, that is the UK and Norway. So the ARPANET has become an international network of computers in this centralized manner. Now, to this ARPANET project, to the ARPA network, there was linked the military network, the US military network, the MILNET, the MINET, which is the European version of this of the American military network, and also the National Science Foundation network, plus because it's time network, that is the BitNet network. So what one can see in the ARPANET project is the growth of a centralized way of information exchange through a mainframe computer to which all sorts of nodes comprising a variety of number of computers, PCs, was the method of the exchange of information. By the 90s, however, the ARPANET project seemed to have been working along a kind of an outdated method of exchange of information. So by the 90s, the ARPANET really passed away slowly and gradually. Now, why is this so? Because from the late 90s, there appears a completely different concept that is going to mark the end of the ARPANET period and mark the beginning of a new period. We are at the CERN 1989 when Tim Berners-Lee, working for the European Physical Laboratory, creates a language, the software side of the linked computers, which is going to be called the World Wide Web. He creates with his fellow people the very means through which computers, nodes, could be linked not through a mainframe computer, in a centralized manner, but rather in a more democratic way when computers, individual nodes, could communicate with each other. The protocols, the means through which, the language through which computers, nodes could communicate with each other directly. Now that is a beginning of the new era. Next year, another absolutely great innovation was given over to the world. That is called the Linux operating system, created, at least its first version, by Linus Torvalds. Now, what links Tim Berners-Lee, now Sir Tim Berners-Lee, and Linus Torvalds is that both of them made these extremely great innovations that enabled the World Wide Web to evolve into what it is nowadays for free of charge. Neither Tim Berners-Lee nor Linus Torvalds made a commercial enterprise of either giving the world the World Wide Web or the Linux operating system, which is one of this latter one is also one of the greatest achievements during the history of the internet. Most of the servers, some people say that even 80% of the servers nowadays run on Linux. So it's a huge success, and yet it was developed, it was made available to individuals free of charge, out of sheer interest. Linus Torvalds started working on his operating system because there was a problem he wanted to fix and couldn't do it with the available operating systems, so he started out of scratch and built his own operating system. The very heart of an operating system is the kernel. Linus Torvalds nowadays is not interested in developing the different distributions of Linux, of the Linux operating system, which could be used not only on servers but PCs and laptops nowadays. So he's not interested in developing these ways of how to use the Linux operating system. He's only responsible, and he kept this for himself, the development of the kernel, the heart of an operating system. What he did, and I'm going to devote a longer lecture to this phenomenon, developed the Linux in a way that he did not only let people use it free of charge, but he also made it open, not only free, but open, which means that the source code was also revealed, so there is no black box. It is revealed, it is open, and anyone can do whatever they wish, tweak, modify for their own advantage the original Linux software. That's why we talk about distributions. This is the way distributions could come into being, like the Ubuntu, Mint, and other Linux distributions that can be downloaded and used for one's laptop or PC as the operating system, instead of using the proprietary operating system systems like Windows, Apple. Now, Tim Berners-Lee created the World Wide Web, the language, the protocols, the ways computers could communicate in 1989, but it was only uploaded to the computers, to the infrastructure in 1991, that is 2 years later. Now, back then, however, the World Wide Web was not something that one could easily use. They didn't have the graphical user interface, nice and shiny as it is nowadays, and also it was very difficult to find information on the new World Wide Web. One of the reasons why it was very difficult to use the World Wide Web back then was that there was no such thing as commercial web browsers. We use the web browser for doing all sorts of things on the internet through the World Wide Web. But back in the very early 90s, the web browser as a concept, especially as a commercial one, did not exist. People, of course, created their own, roughly speaking, web browsers for the sake of having searching and doing stuff on the World Wide Web. But there was no commercial. It was only for the nerds, the elite, the software engineers. So the real breakthrough that made the World Wide Web useful for the public, for the lay people, came only in 1993 when Mark Anderson and Eric Beiner released the first commercial web browser people could buy, and that was the Mosaic browser. And from that time on, more and more people could make use of the World Wide Web as it was nowadays, and it could develop into the World Wide Web we know nowadays. But of course, the story did not end with the first commercial web browser, the Mosaic browser. But it was rather the beginning of a story which still is to be lived, of course, to be written as well, because it is to be lived, because we don't know the end. Nevertheless, from 1993, we can distinguish a variety of stages of development of the World Wide Web as we know it nowadays. And these stages, the description of these stages does not mean that there was a phase which we call Web 1.0 or the static web, and then it was replaced by the next phase, but rather we can tell the story in terms of the development of these phases, but also we have to add that one phase did not die out, and it was not replaced by the new one. Rather, these phases are still with us, at least conceptually. So when there is the new phase, the old phase does not disappear, but becomes integral part of the next one. So, the story of the World Wide Web began in the 90s with what we call the first stage, Web 1.0, that is the static web. 1.0, the static web. This means that back at this time, the World Wide Web was seen and created out of static web pages, and these static web pages were uploaded to the internet by institutions. And back this time, what people could do, lay people could do, was not anything like contributing to the contents of the web, of the World Wide Web, but rather to use it, the static web pages, for the sake of gathering information. So, for example, an institution such as a university placed its courses, or let the rest of the world know about what kind of courses they had, with uploading this to the internet. And people who were interested in what kind of courses that university offered could check that, or search for a course and find the web page uploaded by the university. Now, at this phase of the internet, what was also important was that these web pages that were uploaded to the World Wide Web by institutions and organizations could be thought of as authentic sources of information. Institutions were responsible for them, and they just uploaded what they thought should be shared with the rest of the people for the sake of informing them. So back in the 90s, one of my experiences was that I was about to go to Stratford-upon-Avon to do some research. And when writing up the application to get the scholarship, I had to come up with a research plan, and it would have been good, and it was good to show to list what kind of books I wanted, or journals I wanted to check out and read that pertain to this particular research plan. And I did, and I collected all sorts of material, titles and authors whom I wanted to read. But of course, it was not that simple, because from Hungary, I could only use the catalogs of libraries that I knew. So it was a really limited source of information, and I was really not happy about the list of the bibliography that I created for this research project. And it was by chance that I visited a friend of mine, a relative of mine, actually, in a small town in Hungary, and he was a librarian, not a practicing, but at least somebody was working with libraries. And when I visited him and I talked about my scholarship and the bibliography and the problems of bibliography, he said, "This is no problem. We should check the website, the online catalog of the library of the Shakespeare Institute in Stratford-upon-Avon, which was the destination where I wanted to go, and then compile a list of readings for that." And I said, "How can you do that?" And he showed me. We used the telephone wire to get access to the internet, which took some time, and then very slowly we got to the webpage of the library of the Shakespeare Institute, and I could collect very interesting books and journals to be read, and these seem to have been very nice on the research plan, because my application was accepted and I could go to Stratford and do research in the library of the Shakespeare Institute, which became the foundation for my doctoral dissertation back in the 90s. So Web 1.0 was the static web, when one wanted to find or could find authoritative information on the World Wide Web. This is, however, just the beginning of the evolution and the revolution that came into being with what Tim Berners-Lee did back in 1991. Because this led slowly, step by step, to the new phase, the Web 2.0, so-called social web, in the development and evolution of the World Wide Web. Social web began when more and more users of the internet, individuals, lay people, could add content to the World Wide Web. The story goes back to the late 90s, when blog technology was developed. So the technology, the platform, was created for writing a kind of a diary on logs and upload it to the World Wide Web. So this is 1998, when blog technology starts evolving. The same year is also very important, because this is the time when Larry Page and Sergey Brin, at the beginning part of their doctoral PhD dissertation or PhD research, but later on they just left the confines of the university to launch one thing that was going to revolutionize search on the internet. Because by this time, content on the World Wide Web became so vast that it was very difficult to find something. So there was a need, a growing need, for effective search technologies. And Larry Page and Sergey Brin launched Google, that has become so much part of our life that this is reflected in the evolution or change of language as well, because Google has become a verb standing for searching on the internet. If you don't know something, you just Google it. What they did was a very interesting project. They said that it's all too slow and really impossible to find things on the internet if you just create a search engine that crawls the web if you have a question. So instead of that, they said that what you have to do, which was laughed at the beginning, but seems to have been the one of the solutions, at least one of the possible solutions of search technology, is that you have to, they said, they're going to download the entire internet, index every web page, and then you can search for strings on the internet at a very fast pace. So if you nowadays Google a string of letters, say Hamlet, within seconds you're going to find millions of hits that that might be useful. Now, of course, this was a great achievement, but this is still not the right solution. Okay, it is fast, but how can you find the one that is relevant, or the ones that are relevant for your search, if there are more than 100 million hits for the search term? So the next, or a parallel problem to be solved was how to present the most relevant search hits for the search. The solution imitated, to some extent at least, the academic world. In the academic world, well, at least theoretically and ideally, the most relevant, the most reliable sources, journal articles, books, are the ones that are quoted the greatest number of times. This means that, for example, there is an article which appears in the footnotes of of other articles once, and one that appears thousands of times as a reference in other articles or books. And this will tell the rest of the authors that this one with the greater number of references will be a more authoritative article than the one with one or without any. Now, this is the way that web pages were ranked. This is the methodology that was called, from the name of Larry Page, the PageRank algorithm, which meant that the PageRank ranks this algorithm ranks and ranked. Today it has changed radically, but still at the beginning it ranked hits of pages, of web pages, by the number of links referring to that page and links, hyperlinks embedded in the given web page. So references, links in this democratic World Wide Web placed individual web pages on the list up or down. The 21st century, the beginning of the 21st century, was marked by an iconic, the launch of an iconic project, which we nowadays call, and even back then, it was called Wikipedia. The icon of what is the social web. A democratically built bag and collection of knowledge, of common knowledge, common wisdom. 5 years later, Mark Zuckerberg launches Facebook on the 26th of September. The icon of social web. People follow each other, learn about each other. This changed, actually, the Facebook changed the world. People started shooting selfies, telling each other what they had for breakfast, So in a sense, the world and private lives opened up for friends, that is, people who follow you and you followed back, or friends friended and friended back. So the Facebook is built upon a mutual on mutual friendships. So you cannot really see anything that was not either liked or shared, at least, by someone you know. So it is based on mutual relationships. Another social platform was launched the same year, 2006, somewhat earlier, in July, which we call the Twitter. The CEO was Jack Dorsey. And again, that's an absolutely great success story, similarly to Facebook. I think, less popular in Hungary, but elsewhere in the world, it sometimes beats the Facebook. Jack Dorsey thought that back at the beginning of the 21st century, that communication within his company was not smooth and fast enough. The email, as a method of communication within the company, did not accelerate exchange of information, but sometimes made it impossible, hindered fast communication. So he created on his own intranet, on the company's intranet, a method of exchanging information very fast, based on the length of a text message, with an even shorter one. For a text message, you have 160 characters, whereas on this intranet communication system, you were allowed only to use 140 characters. And when it proved to be very efficient and beneficial, accelerating exchange of information, you put it out on the internet, this application, which he called Twitter, where you could only send messages, actually make blog posts. This is a micro blogging platform, which ran back then into 140 characters only. But later on, around 2016, the number of characters for a message was doubled. So nowadays it's 280 characters that you can squeeze into one blog post. People will read it either if they follow you. You don't. So it's not based on mutual relationships as the Facebook. It is a one way. If you follow somebody, you can read their messages, their blog posts, micro blog posts, or and they will not read yours. So it's not mutual. It's not based on mutual relationship, but on a one-way method. You can only read posts by those people who you follow, or, and that is another great advantage of Twitter, is that you can search among tweets by searching for hashtags. So if I post a blog post on Twitter hashtagged Shakespeare, everyone who follow or search for hashtag Shakespeare will find my tweets. So the tweets you read are based on either social relationships, you follow somebody, or on thematic relationships that you're interested in a topic which is hashtagged by the topic. One tweet can be enriched with several hashtagged words, and then you can read them as well. So a topic-based and social-based possibilities are at hand in Twitter. Twitter is Twitter is a beneficial tool for research as well, for studying. I have learned much about Shakespeare and almost everything with the help of Twitter. Because in a tweet, you can't reveal much. You can come up with a long argumentation, fine. But in a tweet, you can share a link, for example, pointing at a blog post, a traditional blog post where you can develop an argument substantially, or to an article, a book, to a debate. So it's really a device of learning something about a word, and instantaneously you learn what digital humanists, Shakespeare scholars do at the moment. So you have information in topics or in people instantly, instead of waiting for the long time of print or publications coming of the press, either digitally or in print. So Twitter is very good for exchange of information and instantly knowing what other people are doing in your field of interest. Of course, one can follow celebrities and influencers, but at least for me, this is rather for scholarly activity. I follow almost exclusively scholars to learn what they are doing. And also I share with the world whatever I do and whatever I achieve. So Twitter is a means of scholarship nowadays, at least for me. Now the Wikipedia is really an icon of Web 2.0. It represents a great number of the virtues of Web 2.0. First and foremost, Wikipedia follows the great and noble tradition of enlightenment, in a sense that they think that human knowledge can be broken down into manageable bits, and it's possible to define that smaller bit. But it uses modern technology, social web, so it makes it possible what, for example, book culture could not achieve, that is the free access to knowledge. You don't have to pay. If you have a device and internet connection, you can learn whatever you wish from the internet, from Wikipedia. It's not only free, but also open. Anyone can write up an article, about the topic they know the best. Wikipedia has another virtue which makes it an icon of Web 2.0, and that is crowdsourcing. Instead of centralizing information in the hands of a small number, limited number of scholars, Wikipedia says that it's not that they request experts to write about something, and you can choose only from the ones that you know or have published about it, but they crowdsource it. They let anybody contribute, anybody who might have an interest in something. So instead of centralizing, they crowdsource the task. Crowdsourcing is one of the key elements of the World Wide Web as it is seen nowadays and as it is experienced nowadays. Wikipedia is also a great icon of Web 2.0 because it enables collaboration. Somebody starts writing an article about a topic, then other people will contribute, will check. So there is a collaborative activity in Wikipedia, making the articles written by one person better and better with every new contribution. It follows a democratic model. That is, anyone can. You don't have to prove that you're an expert. It is the article that will prove your expertise. And if it doesn't meet the expectations of a Wikipedia article, it may be, at the worst case, or when it seems to be useless, deleted, or other people who are more well versed in the given topic will develop the article, the Wikipedia entry, so as to make it acceptable and of high quality. Which, however, leads to the modification of the concept of the author. In previous lectures, I talked about the author as the creative genius, the individual who goes hand in hand with nature, divinely inspired to create something on his own, almost out of nothing. This concept of the author is softened up clearly with Wikipedia because of the democratic and collaborative model Wikipedia is based on. Someone starts writing about a topic, then another person will add something to it. So it's not the work of an individual, but rather it is a work and a product of a community. So the romantic concept of authority of the author slowly and gradually has disappeared because of Wikipedia. Of course, this has nothing to do with printed and published material, but the World Wide Web as it is nowadays is moving in that direction. Also, Wikipedia can be an icon of Web 2.0 to the extent that the data that is, for example, a Wikipedia page is not on your desktop, desktop and is accessed by those people who you let into your computer, but the content is at a remote server. Metaphorically, this remote server is known cloud. Okay, so these are kept on, these pages are uploaded, are there on remote servers that are accessible to anybody who has an internet connection. So the data is there in the cloud. This is an iconic aspect of Web 2.0 and that of Wikipedia as well. Also, that you do not only upload the data, the final product, to the web servers of Wikipedia, but you can also work already on the Wikipedia page. So you don't need a word processor on your computer, but you need a web browser, and through that web browser you can have access to the web page of Wikipedia, where you can edit and write your Wikipedia, your future Wikipedia article. And when you're finished with it, you just share it with the rest of the world. But you already not working on the applications downloaded to your computer, but you can work directly in the cloud on remote servers. So what are the characteristic features of Web 2.0? There is a movement from the desktop to the webtop, meaning that you don't need a word processor downloaded to your computer, to your laptop, to your PC, but if you have an internet connection and also a web browser, you can go, say, to Google Drive and write your papers over there and have access to this paper from a variety of hardware. You don't need much on your desktop for the sake of working. Webtop is the new sexy. Collaboration, working together. Again, Google or Wikipedia are good examples for this. You can work on the same. Many people work, for example, on a Wikipedia article, but only successively, whereas with a Google document, many people at the same time can work on the same document. Also, cloud services are a characteristic feature of Web 2.0. That is, the cloud becomes the workplace and the storage device as well. This is the time of podcasts, blogs, vlogs. This is, and you can easily follow blogs with and web pages, changes on web pages with the help of RSS feed, the RSS feed. So with an application like Feedly, you can keep track of changes of the blogs, vlogs, whatever you like. Also, you don't only have to for example, bookmark relevant web pages for your research, but you can share this with the rest of the world through social bookmarking services like Delicious, a social bookmarking service where you put all your bookmarks and other people can use your collections for their sake. Or social networking like Facebook, Twitter, and other similar social networking platforms. Now, an extreme amount of content, data, gigabytes of information are petabytes of information upload it to the internet day by day, hour per hour. This means that one can talk about an information overflow, how to find something that is relevant for you at the moment. Web browsers and search engines until recently only searched, as I said with respect to Google a moment ago, searched for strings of letters. And it was only the ranking that helped you finding the relevant information. But what the search engine was doing was that it was searching only for the string of characters. It didn't know whether the word um, um, the word the word page referred to um, page of the book or Larry Page, a human being. What Google could do was was helping the search engine focusing on relevant information with the technology that we call contextual search. That is, you enter the word page and then add further words. You create context for where the string of letters may be relevant for you in which web pages. So you can add to page Larry, you could add Google, you could add PageRank, and then it's very likely that those pages will get higher on the list of hits that include the other search terms. This is called contextual search. But what this type of search motors, search engines disregards is meaning. Meaning, however, is what would make search more productive, more beneficial, and more useful. This is the third, and this would mark the third stage of the internet, which is called the Web 3.0, which is otherwise called with human words semantic web, that is a web that is based on meaning. Now, at the moment, meaning is still not possible to be attached to search engines, but one can semantically enrich through a variety of standards, through a variety of methods, web pages, which will make the web pages readable for the machine, for algorithms, not necessarily for humans. We don't even see this on the web page, but it is embedded in the web page, meaning tags, for example. And this way, you could come up with a web page or a search engine which will find things that seem to be semantically arranged. That's to do this, as I said, all sorts of standards embedded in web pages are used, languages, markup systems are used to enable semantic web. But it is more, if we want to name this phase more precisely, with the words actually of Sir Berners-Lee, would rather call this phase of the World Wide Web as semantically linked web, when web pages are linked through tags embedded in web pages according to some standards, so that the algorithm, would be able to create links between and among web pages. For example, instead of searching for flight, one would how can I search for an answer to the question, how can I spend a week in Paris? And then the semantically linked web would provide links to flights, where you can buy flights, also to hotels linked to the flights. So the journey is created with the help of the semantic web. Also, the accommodation. Of course, you need traveling within Paris, so suggestions how to travel within Paris, what to check out, what you can find there, which is the cheapest, which is when the thing is open. So a complete way of finding your way in the chaos and democratic chaos of the World Wide Web is helped with meaning, when meaning becomes the means through which you can find relevant things for your question. Now, I have to tell you that this is, in a sense, at work nowadays. For example, Wolfram Alpha seems to be, or advertises itself as, the next generation search tool. Here is an example for it. Okay, let's see how Wolfram Alpha, this new generation of web browsers, works. It is developed for mathematical, the solution of equations, and it has a pro version for which you have to pay, but also it has an open access, a free of charge use to show what it means, what extent this is new generation of search engines. For example, we can ask stuff about we would like to know. You can do all sorts of easy and everyday types of searches, and it will answer a variety of questions. For example, I can ask, am I fat? And let's see what kind of answer it gives us. Of course, you should add. Okay, let's talk about a hypothetical man. Okay. Roughly the height is given, and it's good to add the gender as well. And so we have all the information: 90 kilos, 175 centimeter height. And let's see if the person is fat or not. The information is given, the way, the method how this body mass index is calculated, and then it tells us that if we classify people in a variety of ways, the person with 90 kilos, men, and 175 kilos would be overweight. But what does this mean? That here is a chart telling you the range of people being underweight, the range between the data or the limitations between which one is of normal weight, then the overweight range and the obese range also presented. So fat, this tells us that fat, the word fat, doesn't really mean anything, but rather includes variety of further layers, and this is where one should find oneself. Of course, we can do something more complicated, more cultural, such as Much Ado About Nothing. It already provides this. So let's see what it can tell us. It tells us that it's a play. It has a full title. It's a play written by Shakespeare, published first in 1600. The publishers were Andrew Wise and William Aspley. Here is an image, how many acts, scenes, and characters there are in this play, number of words, longest word, average word length, terms of characters, number of unique words, the most frequently used words, and you can have more of them, most frequently capitalized words. Well, you're not surprised that personal pronoun and names appear in this list. Most frequently used bigrams or two-word phrases, a number of sentences, average sentence length in terms of character words, and also words spoken by different characters. It's quite fascinating that Beatrice is almost as talkative as Don Pedro. We can see when different characters speak the most in this heat diagram, acts and the contents of different acts. So all sorts of very important and interesting information about the play William Shakespeare. Of course, Wolfram Alpha seems to be a semantic search engine, but actually it works with a limited set of data. It's based on Wikipedia most of the time. Much more and similarly interesting enterprise, again, almost very close to semantic search engines, is based on Google Books, and it's and the method of finding information is arrived at with deep learning, vector deep learning, which may be called an experimental artificial intelligence engine. And this means that you can ask questions like, what is the meaning of life? What is the meaning of life? And it will find answers to this question with the help of Google Books. So one possibility is, for me, the meaning of life is to serve one another for the survival of humanity and the advancement of civilization. This definition is found in a book published in 2019, written by Newton Lee. The title of the book is Transhumanism, and you can also find the context of this, for me, the meaning of life. Right. Naturally, you can ask different questions. Other questions, doubling in roles, for example. Again, you have to find the right keyword, but again, you can find um, um, answers to this question in very relevant scholarly books. In performativity and performance, in the second mode of doubling, one actor plays more than one role, two or more masks here. Okay, having seen how Wolfram Alpha works, one realizes that what is at stake in Web 3.0 is search and searchability, how to find things with ease. And also Web 3.0 is going to is the place where machines start communicating with each other. Like an example for this is the Internet of Things. Now, this has been the horizontal, the historical approach to the World Wide Web, but this is not the only method of describing the context of digital databases. And from here, we move on to the different layers of the World Wide Web. We distinguish conceptually three layers of the World Wide Web, which are sometimes in everyday language mixed. So we should make a clear distinction between the three layers. These three layers are the surface web, the second one, the deep web, and the third one, the dark web. Let us start with the surface web. This is the layer of the internet that you can easily access if you have any commercial, free, open source, occasionally open source web browser. Any one of them should enable you to find things on the surface web. Most of the time, the extensions of the URL addresses comprise of org, com, edu if it's an educational institution, or an abbreviation of the country name. So NZ for New Zealand, AGU for Hungary, RU for Russia. It's very difficult to tell how much of the web belongs to the surface web. Some estimates claim that the surface web, so the easily accessible collection of web pages, only constitute 10% the internet, which is a very bold and very interesting observation. Now, from the surface web, if we go deeper to the rest, to the 90% of the web, first we should talk about the deep web. The deep web is that layer of the World Wide Web which includes web pages that are password protected. So it is not enough just to have a web browser to have access to this layer of the World Wide Web, because you need methods to get to these pages. This may include bank accounts, and it is very good that no one besides me has access to my bank account. It is password protected. Not just password protected, but two-step, three-step, many-step protection is used. But these are the web pages that are protected by my password. It's good that people cannot see the history of my bank account, cannot send money to another bank account or other individuals from my bank account. So it is quite good and necessary. Not so important, but still important, is that not everyone has access to my email account. Not all people can read my emails, and not all people can send emails from my account or my Google Drive, because all these are web pages, part of the World Wide Web, but made inaccessible to most of the people. And that's why one can say that this is really a large amount uh, um, of web pages of the World Wide Web. Also, if you want to read a scholarly article, sometimes you can't do that because some of the pages, some of the um, journals, some of the articles are behind the paywall. So you're not allowed to read these content, these pages, only if you pay the subscription fee to them. So password protected pages or contents behind a paywall make up what we call, rigorously speaking, the deep web. And still, this is not the entire story of the World Wide Web, because we have a further layer of the World Wide Web, which is called the dark web. All sorts of negative associations are linked to the dark web, that you can do whatever you wish there. All sorts of illegal activity is, you can buy drugs, you can buy guns, you can buy a hitman, or uh, um, people, even people. So very, and if you watch videos on YouTube about the dark web, you will always learn that once you enter the dark web, you're exposed to prying eyes, people can hack your computer, whatever. Now, of course, there is, if you call it a dark web, it's and the word dark appears, it all sorts of negative connotations um, starts showering. But I mean, this is not the dark web, really. Part of it, yes, but this is not the whole story. If you if you want to give a precise account of the dark web, one has to say, define it as anonymous networks. This means that you just cannot, with a web browser of any kind, enter these networks. So you need special equipment to enter these private networks. And also, the aim of these networks, of these layers of the World Wide Web, is to keep your anonymity, to keep your privacy. Of course, this entails you can remain anonymous, then you can do all sorts of illegal activities, but that's not the whole point. The web browser that you need to enter one of the largest private networks of the dark web is the Tor browser. So whereas the surface and the deep web can be accessed by any web browser, for the dark web, for these private networks, you need special web browsers. One of them, the Tor. You can download the Tor web browser free of charge. It is open source. It is built upon the Firefox web browser. And with this web browser, you can browse both the surface and deep web, and also this is the gateway to a private network of the dark web. Now, what is quite interesting is that one might think that that was created for the sake of by criminals fostering criminal activity. However, this is not not the whole story, and not the story of the Tor browser and the Tor network, private network. It started very early in the 90s in the US with an encryption project. The encryption project, the narrative for this encryption project, the need for this encryption project was this. Even in the 90s, spies, information agencies wanted to enable their agents, their spies, to be able to communicate through channels that cannot be broken by anybody, because the agent on the field needs information. He has to use the internet. He has to use communication technology as fast as the internet. But if the information is leaked through the channel, when the information gets from a point to point B, point A to point B, then the agent might be misinformed, the agent might be killed, which is not the idea of information exchange. So in the 90s, there was a need for creating a method of encryption. Now, the method of encryption for the Onion project is the following. It's like the onion that you have to peel away surfaces of information and bits of information to get the entire onion. So how is this done technology wise? When from person A, a piece of information is sent over to person B or point B, then when the information is sent, it is broken into small bits, unintelligible bits, and they are sent through millions of channels in these pieces, bits and pieces, and the information is put together only at point B. So if the information is caught between the sender and the receiver, the bit of information that is caught will not make sense. So the information is intact and complete only at the receivers, the senders end, and only at the receivers end. So the information is broken into pieces. The different pieces are sent to the receiver via different routes, and the information becomes complete, is put together, pieced together only at the other end of the information channel. Now, this method and also the Tor project, besides breaking the information into pieces and sending it via different routes to the receiver, also aimed at concealing the site from where the information was sent. This means that each and every send message, say sent, can be traced back to an IP address that identifies a specific computer which is at a specific country. Now, the encryption technology that is used in the Onion project with the Onion router blurs the IP address of both the sender and the addresses of both the sender and the receiver. Now, there is an easy, practical, not so illegal use of the Tor browser nowadays when browsing the surface net is, for example, can follow the following scenario. Let us suppose that you are interested in a YouTube video that you'd like to watch. And it can happen to you, however, that when you open the video in Chrome or in Firefox or Edge, instead of the video, you get an error message saying that this content is copyrighted in your country, you cannot watch. So it's over there, the video, it's over there on the server, but you have no access to it because of copyright issues linked to your country, which the YouTube site knows because it can identify your IP address. Now, some people think that you can do this with a private window in a web browser, but actually the private window does not do this. The private window only enables you or disables really the web browser to save your search, but the target web page can read your IP address. So it's private to the extent that the next person using the same computer will not know your, say, searches, or your or the web browser will not recall your passwords, but the target web page will be able to identify your place. So YouTube can tell you that you cannot watch the window because it has identified your IP address, which is linked to a country, and then in that country you don't have the copyright, the legal means to watch that video without paying. So what you can do, opening the Tor browser, you can switch to another country to the extent what the target webpage will see, and then you can watch the video because, say, in Nigeria, that material is not copyrighted. You switch to a Nigerian IP address, and then you can watch a video. Now, this was very good and worked for NASA and all sorts of agencies around the world to protect data this way. But after a while, this project, the Onion project, and the Tor, the Onion router is the extension of the abbreviation Tor. So the Tor browser was made open source in 2002. So from that time on, anyone could use. Clearly, agents moved to another channel. Anyone could use this browser and could enter that section of the dark web that was open for the Tor browser. Since 2006, the people responsible at the agencies, Roger Dingledin and Nick Mathewson, keep the Tor project alive, update it, and work on it. So what's important in this project is that it was developed by secret agencies. You see, this is important because the dark net is associated with illegal activity, and illegal activity goes on over there. But that doesn't mean that it was developed by people who focus on illegal activities. And also, I have to share this doubt that complete anonymity is not impossible, and it's not by chance that it was made open access in 2002 and is kept alive, a project that was devised by information agents. So it is defined by the method of encryption I talked about, and also one should talk about the users of the Tor a private network. On the one hand, it is true that all sorts of illegal activity goes on in the Tor private network. The famous Silk Road of the Tor, ran by .com, who the hacker, the person running on alias.com, you can really buy anything on the Silk Road, from weapons, from drugs, whatever, keeping your identity, paying with bitcoins, whatever. This is not the whole set of users who are engaged in illegal activity. Users are just can be everyday people who think that their anonymity, not leaving digital traces, the World Wide Web, is important, for whom privacy matters. Use the Tor search web browser, or even the Tor private network. Also, organizations that for which anonymity is important might use the Tor. It is known that, for example, news agencies have their platforms on the in the dark web, because they want their sources of information to give information and keep their anonymity. And at one level, this anonymity is kept, and privacy is secured on the dark web, because people can upload their files to the Guardian's, to the New Yorker's page on the dark web, with saving themselves from prying eyes, and without revealing their identity openly. Of course, I mean, some people have to know their identity because they have to verify these sources, but the very act of giving the information, providing the information, is kept in secrecy. Also, for example, Sci-Hub has its site mirror page on the dark web. Well, now the dark web of Tor is made up of web pages where the URL address is not easy to use. You cannot just search the dark web as you can search the surface web. One reason for this is that the web pages, the name of the URL addresses, the web pages are not intelligible. It's every web page has a URL address consisting of two major parts. Of course, these two major parts, similarly to the surface web, are divided by a full stop, a dot. But before the dot, instead of sci-hub, say, you have a long string of numbers, capital and not capital, and numbers. You cannot memorize a web page like this, and it's not meaningful. You cannot search for a web page by the name of the URL address. And after the dot, instead of com, org, or an name of abbreviation of the name of a country appears, but always the same, onion. Okay, identifying the dark web of Tor. So what is the significance of the dark web of Tor? Anonymity, privacy, and one can, and as I have said, even cultural products appear in all layers of the World Wide Web. From the surface, you can go to Europeana and find stuff there in their database, or some of them are behind a paywall, such as JSTOR, or some elements of culture even can be accessed only in the dark web, the Tor. The dark web of the Tor. For example, as I said, Sci-Hub has its own platform in the Tor dark web of Tor. So anonymity, lack of digital footprint, and privacy are all there in the Tor, which is a private network that can only accessed with a special web browser, the Tor browser. So today I talked about the context in which we find digital databases nowadays. This has not always been the case, but this is the case nowadays. And the context, and I explored this context with reference to the horizontal development and evolution of the World Wide Web and the Internet. And I tried to relate the two each other as two sides of the same coin. And also, I explored the different layers of the World Wide Web, the surface, the deep, and the dark, and I also related these to cultural phenomena and cultural database. Well, so thank you. I have completed my mission, and thank you very much for your attention. See you in the next video.